So what if we take this information and use these factors of 80 that we were talking about before, this global warming potential, and try to add that to these bars that show the CO2 emissions that I showed earlier for the average power plant. This is just what's coming out the stack, but we also need to account for all the emissions that are occurring upstream. And so if we take all the data that we collected, and you can come up with a new estimate of what methane emissions are, and I've just added it to the bars here showing with a little bit of red, and you can see that there's, the green bar isn't nearly as short anymore, right? That's the natural gas bar. And essentially there is a bunch of methane emissions. It eats up a bunch of the potential climate benefit, which is bad, but there's still a net climate benefit. So you get progress with respect to climate change by switching to natural gas, even with this leakage. So I think that's good news. And there's still uncertainty. I don't have that represented up there. There's still uncertainty associated with that. But there's also an opportunity. That red bar represents an opportunity, because if we can squeeze that down by reducing that leakage, we get more climate benefit. Not only do we get more climate benefit, but the companies get to sell more gas, because that's their product, and right now it's going into the atmosphere. And so I think there's a possibility for a win-win. And we'll talk about, how do we go about, what does our measurements tell us about how do we go after that win-win. The final point from a climate perspective is this is really thinking about kind of a near-term transition, right? If we go from coal to gas, so we reduce our carbon intensity of our energy system. But if we're looking long-term and to stabilize climate, we really need to reduce our greenhouse gas emissions by 90% plus. So just going from coal to gas, even if we completely eliminate the methane, completely eliminate that red bar, if you look at this image, we still have a long way to go. And so natural gas isn't the end solution, but it could be a nice step. And certainly getting rid of the methane would help. So there is this methane emission, we want to squeeze our red bar. How do we go about squeezing the bar? Well, we need to know something about where the methane's coming from, and that's what this figure is showing here. So this is just data from the northeastern Pennsylvania campaign. And what it shows is a distribution of the emissions, right? So on one axis, it's the facilities, and the other axis, it's the fraction of emissions. And I'm not going to get into the details of it, but what it basically shows is that 80% of the emissions are coming from 20% of the facilities. And so if we're thinking about reducing emissions cost effectively, we want to know what are those 20% of the facilities that are creating 80% of the emissions. Because if we could fix those facilities, we can get a long way to fixing the problem. And if we could do that effectively by identifying them, that would be a real win. And so I think that's the opportunity. So that was one of the things that we learned. Not only did we get emission rates, but we have this idea that the emissions are what we call very skewed. So how do we go out and screen those facilities? And so this again is the map that I showed earlier of northeastern Pennsylvania. And so I said we went out for 6 weeks with our truck, very sophisticated instrumentation, a team of people, and we measured emissions at sort of 40 to 50 facilities. But if you look around, there are all these gray dots that we don't have data for. And so which are the high emitters? I can tell you of the red dots which are the high emitters, but if we're going to really reduce the problem, we need to know across all the facilities what are the high emitters. So we need more rapid screening techniques in thinking about that. So one idea that's been done a little bit is actually to do airborne screening. And so you mount an IR camera on a helicopter or a UAV, and you can fly very rapidly over these facilities and screen all the facilities. As opposed to the ones that we got in 6 weeks, you can screen this whole field here in less than a week. And you can identify which are the facilities that have large plumes and which facilities don't. You can identify which ones that you'd want to go and address. And that's again what this is sort of showing a little bit more information. This image is just showing some IR camera images from a helicopter. And they've done this in some basins already. And they can screen thousands of facilities in periods of a week or a bit more than a week. And they usually find 2 to 4% of the facilities have these sort of high emitting sort of characteristics. You don't get the same level of data from the helicopters you do from the ground-based measurements, but I think you get enough information to start making sort of intelligent decisions about where you want to put your sort of repair funds.